We spoke in the first video about the first type of electric circuit, that is the series circuit, where the lamps are connected one after the other to form one loop. In this video, we will speak about the second type of electric circuit, when the lamps are connected above each other, where if you take a close look, you'll observe that each lamp forms a single loop with the dry cell. Then, the lamps in this circuit are connected in parallel. So, in parallel circuit, all the electric components are connected in two or more loops. Your friend have a question asking if the current passing through the lamps is the same as that of the dry cell in parallel circuits. It is lab time to find the answer. This is an electric circuit where the lamps are connected in parallel. To find the intensity of the main current that's sent from the dry cell and the intensity of the current of the lamps, we should use 3 ammeters that each is connected in series with the corresponding electrical component. The intensity of the main current that's sent from the dry cell is 1.8 ampere. That of the first lamp is 0.9 ampere. The intensity of the second lamp is also 0.9 ampere. Let's now replace one of these lamps with another kind of lamps. The intensity of the main current that is sent from the dry cell is 0.91 ampere. That of the first lamp is 0.01 ampere. And that of the second lamp is 0.9 ampere. What can you conclude? What is the relation between the intensity of the current of the dry cell and that of the lamps? Look at the values of the intensity of current of the lamps and dry cell that are obtained in these two circuits, then try to find the relation between them. 0.9 ampere plus 0.9 ampere gives 1.8 ampere, and 0.01 ampere plus 0.9 ampere gives 0.91 ampere. So, the sum of the electric current of the lamps connected in parallel is equal to the main current of the dry cell. Let's take it from another point of view. If you remember, we resemble the flow of the electric current by a flowing river. Look at this picture. It is a flowing river that reaches two branches. Then the river will be divided, and if you sum up these parts, you will return to the main current. This idea is very similar to what we did in parallel circuits. The electric current reaches to two branches, then it is divided, and at the end, they are added to return to the main current. What is the relation between the voltages of lamps and that of the dry cell? Let us go back to the lab to find this relation. To measure the voltage of these components, we have to use the voltmeter that is connected in parallel. The voltage of this lamp is 9 volt, of that lamp is also 9 volt, and of the dry cell is 9 volt. What does this mean? This means that the voltage of the dry cell is equal to the voltages of the lamps when they are connected in parallel. You have to keep in mind that in parallel circuit, all the electrical components are connected in two or more loops. And in this connection, there are two laws. The first law states that the intensity of the current of the dry cell is equal to the sum of that of the lamps. And the second law states that the voltage of the dry cell is equal to the voltages of these lamps. Do you think that the electrical components like the lamps, refrigerator, iron, television, and others that are found in your home are connected in series or in parallel? Look at the rated voltages found on each component. All of them need the same voltage to work. Then they must be connected in a way so that they take the same voltage. Also, if one of the lamps in your home is burned out, what will happen to the other electrical component? Nothing. Nothing will happen. All of them still working normally. Let's take a closer look with an example to know if the connection in our homes are in series or in parallel. Look at these bridges. They are connected one after the other in series. You can cross these bridges easily. But what happens if one of these bridges collapses? Can you cross to the other side? No, you can't. This is a disadvantage of a series circuit. A break in any part in the circuit or burning out a lamp stops the flow of current in the whole circuit. Another disadvantage of a series circuit is that the more bulbs we add to the circuit, the more dimmer they become. Now, look at these bridges that are connected in parallel. What happens if one of the bridges collapses? Can you cross to the other side now? Yes, because you can use the other bridge to cross to the other side. This is an advantage of a parallel circuit. When there is a break in one of the branches in the circuit, current will still flow to the other branch. Also, the brightness of the bulbs remains the same since every loop is independent. So, can you tell me now what is the type of connection found in our homes? Of course, it is a parallel connection because if one lamp burns out, the other components still function normally and the voltage is the same in all the electrical components. Now, can you explain the chandelier and the decoration light problem you had earlier? Only one bulb of the chandelier burns out because it is connected in parallel circuit. That doesn't affect the brightness of the other bulbs. But for the decoration bulbs, all of them stop working because they are connected in series. One broken bulb will stop the flow of current to all bulbs. Different appliances need different voltage power sources for functioning, like the torch bulb that needs 3-volt battery to light. Then you put two 1.5 dry cells in this way to let it function. Let us look more closer to the way we connect these two dry cells. The negative terminal of the first dry cell is connected to the positive terminal of the second one. This connection of dry cells is called series connection. To find the total voltage given by these dry cells, you have to add them. Then 1.5 volt plus 1.5 volt gives 3 volt. Find the total voltage in this connection. Because the positive terminal of the dry cells are connected to the negative terminals of them, then they are connected in series. So the total voltage is equal to the sum of these voltages. So 1.5 volt plus 1.5 volt plus 1.5 volt plus 1.5 volt will give 6 volt. So you have to keep in mind that in the series connection of the dry cells, the positive pole of the first dry cell is connected to the negative pole of the second one, and the total voltage is equal to the sum of the voltages of these dry cells.